Good morning. This is your Stats Sensei, Mr. Spensei, and this is Death Packet video problems for the probability distributions, Unit 3B, and it'll be questions 11 through 20. So according to, in the following, which should not be modeled with a geometric? So the key word there is not, and we're worried about a geometric. So let's talk about a geometric. We need binary, yes or no situation. Each event needs to be independent. The successes, that probability cannot change, so same level of success. And we're looking for it to happen on the first one. All right. And that should pretty much take care of us because we start at one and it's going to end on the first. So that starts at one and ends on, and we're looking for the first. So according to a recent study, approximately 8% of adults in the country have a master's degree. Let X represent the number of randomly selected adults in the country surveyed to find the first one with a master's degree. Okay, percent constant. So, and it's either you have it or you don't. So that's good. We satisfy all that, we're good. That's not it. Suppose it's known that 5% of the light bulbs manufactured at a particular company are defective. Let X represent the number of randomly selected light bulbs that are inspected to find the first one. Gosh, we still have a binary. It's defective or not. They're independent. Probabilities don't change. The success is the same. We start at one. We're looking, and we're going to go to the find the first success. Not it. A particular basketball player is known to consistently make 90% of her free throws, and the outcomes of her free throws attempts are independent. Oh, they're telling us they're independent because life they probably aren't, but because they are, um, we're going to let X represent the number of free throws till we get the first one. That's definitely a geometric. In a bag of 30 different colored candies, about 20% are red. One candy will be selected one at a time without replacement. Ooh, that's important. All right. If we're doing it without replacement, our probabilities are changing. Probabilities are changing. That violates independence and probabilities being the same. This is our answer. Answer choice D. Let's look at E. It's believed that about 40% of the people in the country have purchased a certain product. Let X represent the number of people randomly selected to find the first one who has purchased the product. Okay. We have a yes no situation, they purchase it or not. We have independence. We also have same probability. We're looking for the first one. It's geometric. So that's a good geometric. So our answer choice to number 11 is D. Number 12. According to a 2016 survey, 6% of workers arrive to work between 6:45 and 7 a.m. Suppose 300 workers will be selected at random from all workers in 2016. Let the random variable W represent the number of workers in the sample who arrive to work at 6:45. Assuming the arrival times are independent, which of the following is closest to the standard deviation of W? Hey, we have a fixed sample size. So this means we're working with a binomial. All right, with a binomial, standard deviation is the square root of n times p, n times p times 1 minus p. Well, we know our sample size is 300, or we have 300, a group of 300. We know our p-value is 0.06. I wrote the wrong thing. So times 0.06. And this will be times 1 minus 0.06. All right, so 300 times 0.06 times 0.94, because that's the 1 minus 0.06, that's 0.94. Now I need to take the square root of that. It's raised to the half power, and I get 4.11. If I hadn't taken the square root of it, I would have been dealing with the variance. So my answer choice is B. The 1692, that's our variance. Be careful, make sure to take the square root. According to a 2015 Census Bureau, 75,511 of 822,952 residents of Baltimore County, Maryland, were enrolled in college. That's a lot. Consider a sample of 800 residents of Baltimore County, Maryland in 2015 at random. Which of the following is closest to the expected number in the sample enrolled? Okay, so I need to figure out what the probability that they're enrolled. Well, the probability that they are enrolled, probability in this case, is 75, 511 out of 822, 959. All right. Well, since I have a group size, I know that this is a binomial, and the expected value of a binomial is NP, and N is 800. So 800 times 75,511 over 822, 959. So let's go ahead and multiply that out and see what happens. 800 times 75,511 divided by 822, 959. 73.4. All right. And sure enough, we have a 73.4. So our answer choice number 13 is D. During a severe storm, electrical transformers that function independently are expected to operate 85% of the time. They're telling us they're independent. They operate 85%. So this is P equals 0.85. That's going to be probably important. Suppose 20 electrical transformers are randomly selected. Oh, we have a group of 20. The fact that I have a group tells me this is probably a binomial. Let the random variable T represent the number of electrical transformers operating during a storm. Which of the following is the best interpretation of the variable T? First off, we have a fixed number, a group, so we're working with a binomial. It's a binomial. Oh, but they're talking about they're talking about the mean. So let's find out what our mean is. Remember, the expected value for a binomial is NP. So in this case, we have 20 times 0.85. So that's 17. All right. So the expected value or mean is 17. We also know the standard deviation because I see they talk about that as well. And the standard deviation is going to be the square root of N times P times Q. Well, N times P times 1 minus P. And that is 20 times 0.85 times 1 minus 0.85, which is 15%. So 20 times 0.85 times 0.15, that's 81 minus 85. Got to raise it to the half power. Oh, so that's the square root of 255. So it's a binomial with a mean of 17 and a standard deviation of 2.55 transformers. That's right. That's how many we expect to be working on average. All right. Let's look at this. It's a binomial with a mean of 17 severe storms. No, it's a mean of transformers. So this is the wrong thing here. 85 transformers. No, this is not a binomial. No, not a binomial. And it definitely is a binomial. Our best answer choice is A. Number 15. According to a recent survey, 31% of the residents of a certain state who are aged 25 years or older have a bachelor's degree. So P equals 0.31. A random sample, oh, we have a group. If we have a group, we're probably working with a binomial. In this case, N is 50. Let random be the variable B represent the number in the sample who have a bachelor's degree. What's the probability that B will equal 40? Oh, so N is 50, X is 40. And remember, it's N choose X, probability to the X, 1 minus P times N minus X. So in this case, 50 choose 40. The probability that they have it is 0.31 to the 40th power. 1 minus 0.31. 50 minus 40 is 10. So we're looking for something that looks like that. First off, 50 choose 40. That gets rid of this. That gets rid of that. And I don't know what this is. All right. Next, 0.31 to the 40th. Oh, that looks like 0.31 to the 40th. But where did they get that 69? Well, 1 minus 0.31 equals 0.69. That's where that came from. It's to the 10th power. Best answer choice for 15 is A. Number 16. A random sample of N people selected from a large population will be asked whether they have read a novel in the past year. Let the random sample R represent the number of people from the sample who answered yes. The variance of R is 6. Okay, so we know this is 6. Assume that the responses are independent of each other. If the proportion of people from the population who have read the novel in the past year is 0.40, so P is 0.40. Which of the following is the best interpretation of the random variable R? Wow. Okay. So we first off, we have N, which is a large population. Because we know we know we have a large population, that makes this a binomial. All right. Because we not because of the large population, because we have N people. This is our group. We have a sample. This is a group. Because it's a group, that makes it a binomial. All right. So the one that say not a binomial, those got to go away. Problem is I got to figure out how many trials there are. Well, I need to know something. What I need to know is that the standard deviation equals the square root of N times P times 1 minus P. All right, but that's not my variance. But if I square it, my variance is N times P times 1 minus P. Oh, I know my variance is 6. I know this. I don't know N, but I know P is 0.4. And this is going to be 1 minus 0.4, which happens to be 0.6. So let's do that. Let's take 0.4 times 0.6. 0.4 times 0.6 is 0.24. So 6 equals 0.24n. Divide both sides by 0.24. 6 divided by that is 25. All right. We have 25, a binomial variable with 25 trials. So basically, we just found out that our sample size, our group size, was 25. Number 17. A local department store estimates that 10% of its customers return merchandise they purchase. Let the random variable R represent the number of returns for a random sample of 40 customers. Assume that the random variable R is a binomial. What's described by the value of 8? Okay, so in this case, we know N is 40. And what they're asking is what's the probability that we'll have 8 people, exactly 8 people out of the 40 return merchandise. So the probability that 8 customers in a sample will return merchandise. 40 choose 8. All right. There's our 10%. 1 minus 10. We're good. All right. Next, number 18. In a certain region, 94%, so P equals 0.94 of the people have a certain characteristic in their blood. Suppose a group of 45. So, we have a sample size of 45 from the region are selected at random. Let the random variable B represent the number of people in the sample without the characteristic. All right. Random variable B follows a binomial and has a distribution with a mean of 2.7. Which of the following is the best interpretation for the mean? All right. So in this case, they're actually being tricky. 94% of the people have a certain characteristic. All right. But they're talking about without the characteristic. So 1 minus that would be 0.06, or 1 minus 0.94 equals 0.06. And if I go 0.06 times 45, I get 2.7, which is what their value is. So that means if we did this over and over again for groups of size 45, we'd expect there to be on average 2.7 with this characteristic. All right. So let's look at these real quickly. For all groups of 45, the average number of people without the characteristic is 2.7. Possible, not great. Every group of 45 will have 2.7. No, that's not true. It's the average. We don't like this. Every group of 45 will have 2.7. No, don't like saying that. Oh, it's exactly the same thing. Oh, one's with and one's without. On average, 2.7 until we find someone. That's a geometric. On average, 2 point until finding someone without. Oh, also a geometric. We're working with a binomial because we have a specific group size. Because we have a specific group size, this is a binomial because we have n equals 45. And the one that's a binomial that has the says, hey, if we did it over and over again, on average, we expect to have 2.7 is 18. A is our best answer. Number 19. According to a 2018 survey, 74% of employed young adults expect to bring work on a vacation. So P equals 0.74. A random sample of 20 employed workers. Oh, we have a group of 20, so N equals 20. What's the probability that 8? Oh, remember our formula. N, choose X, P to the X, 1 minus P to the N minus X. So in this case, 20, choose 8, 0.74 to the 8th times 1 minus 0.74. 20 minus 8 is 12. So let's look at this. 20 choose 8. I don't like these 12 choose 8s. Those can go away. 0.74 to the 8th. I like that. I don't like this. Oh, this is not good. This should be 0.26. All right, so our best answer choice is B. That should be 0.26. That has to be fixed. All right, so that has an error in it. Sorry about that, guys. All right, number 20. In 2014, 85%, so P equals 0.85. Households in the United States had a computer for a randomly selected sample of 200. Let the random variable C represent the number of households in the sample that had a computer. What are the mean and standard deviation? All right, the expected value is N times P because this is a binomial because we have a specific group. So that's going to be 200 times 0.85. So the expected value or the mean is going to be 170. So the mean is 170. So that gets rid of our first three. The standard deviation. The standard deviation, remember, is going to be for is the standard deviation is for the binomial is N times P times 1 minus P, which in this case is going to be 200 times 0.85 times 1 minus 0.85 or 15, because that's 1 minus, and we take the square root of that. So let's do that real quickly. 200 times 0.85 times 0.15, raise it to the half power, and I get about 5.049. Best answer, letter D. All right, I hope this helped and look forward to seeing you on the next one. Thanks for watching.